Hello everybody. In this video, we are going to talk about Amazon Elasticsearch service. Before we go into the actual demonstration, we are going to quickly cover a few slide decks to understand the basic concepts of Elasticsearch and its underlying components, and then why it is benefited to go into Amazon Elasticsearch service, and finally we quickly go through the demonstration of building cluster and running few commands to create index and upload the documents and everything. So I have few slide decks. Let's quickly go through that. What is Elasticsearch? Elasticsearch is a open source search engine based on Lucens. So it provides a distributed multi-tenant capable full text search engine with an HTTP web interface and schema-free JSON document. It's developed in Java, released as an open source, as I mentioned, in terms of patchy license. So what it means basically, you come with any kind of document in any kind of format. Basically, when you ingest the data into Elasticsearch, this application basically strip down all the individual words and store it in an inverted index format in this way. For example, these are all the IDs of each words, and these are all the actual words stripped down from those documents, and this is the actual index, metadata. For example, let's take the word best. The best is the word located in document 2. If you can go here, best is the word located in document 2. Take a word blue. The blue is the word in both the document 1 and 3. So you have a word blue here and word blue here, 1 and 3. So so the way it is indexed, it's going to be very helpful when you search the data, when you go and get the data. Basically it's used for analytical purpose. Let's say I have a social media data, flood of data. I just want to know a specific word, or I just want to know the maximum number, or I just wanted to grab specific range of data. In those scenario, which is really going to be useful. So this is only for quick search as well as analytical purpose. It's going to be used. Okay. So what is the what are all the components? These are all the components. We talk about NRT. It's nothing but near real time. Elasticsearch is a near real time search platform. What it means, there will be a slight latency from the time you index the document. When I say index, from the time you upload the document to the cluster until the time it becomes available for a search for the user. That's what we don't say. Although it is so fast, it is not real time. Of course, it takes at least a second to index in the cluster level, and before it give it to the user. And cluster. Uh, why we call this Elasticsearch cluster? Of course, you can install Elasticsearch in a single node without a cluster, but people thinking about high availability as well as expanding the data. So all those consideration, mostly it is benefited to use it in cluster environment. Cluster is a pretty much common term. It's nothing but collection of one or more nodes on the server, which is going to hold your data, index and everything. What is node? So every single instance within the cluster is called node. This is where we are going to have our actual indexes. I'll cover what is index and everything. This is where your actual data is going to be stored. And also we are going to talk about master node. See, under the cluster you have so many nodes, so you can have a group of master node or even one single master node and rest of all the data node. So the name itself says master. Basically he is responsible for all the cluster wide actions, like when you do any administrative task, like creating the index or tracking the nodes or checking the health or replicating the data. So those kind of cluster level activities all will be managed by the master node. Why do we need to have, let's say you are going to have a huge production based, Elasticsearch, and that's going to store lots of amount of data. So in that situation, we don't want the data nodes to spend resources on managing the cluster also. So let's have a dedicated guy who takes care of the cluster activities, and the data node will be purely responsible for only writing the data and serving the data back to the user. So that will, that way we are going to have better performance. So this is optional. It's not mandatory to have a master node. It is an optional one. So go through this link. As I mentioned, it's an open source. So if you go to this Elastic Co, you'll find a nice document and much more detailed explanation of each term. I just grabbed very the basic information to just to cover it cover it in this video. And index, this is another critical term. Index is when you store the data into Elasticsearch. Although it is not a database, index is kind of a database actually. We can just correlate for understanding purpose, but it's not really meant. It's a collection of Index is a collection of documents that have somewhat similar characteristics. Basically, you throw the documents the same. Let's say you have data for a customer one, customer two, customer three. So all you wanted to segregate. So customer one data you wanted to store it in index one. Customer two data you wanted to store it in index two, because those are all similar type of data. You don't want to mix and match. So that's where I'm just trying to correlate with the database. We are going to create different indexes for a different purpose or different application. So not to mix and match. So, okay, the second term is type. Within an index, you can define one or more type. So the type is a logical category partition of your index, whose semantics is completely up to you. It's again, it's like a table inside the database. It's kind of correlation once again. You created the database. Okay, inside the database, I wanted to have much more bifurcation, like a partition. Like for example, every day I want to store a data. I wanted to store the data in the timestamp, let's say today's date and tomorrow's date. So you can have a type created in a date wise or month wise or year wise or something, so that it's easy for you to go and search. Instead of searching 1 year worth of data, you can go to the specific date and search. So it's like a table. And mapping, this is mapping is nothing but the schema. You can even create a template map well in advance, so that you can define when the data ingested into the Elasticsearch, this is the type of data I want. I mean data type format. It should be integer or string or date format. So those things you can define well in advance, so that if anything other than that, Elasticsearch will not take it. So that's something you can predefine. That's what mapping. And finally, the document. The document is the actual piece of data which is going to be inserted or ingested inside, written into the Elasticsearch. Finally, it's going to the index. And shards and replicas. Um, Shard is nothing but the logical partition. I have a next slide which will explain much better. And replication is keeping the multiple copies for high availability. So these are all important terms. As I mentioned, go to that link, Elastic Co, which will give much more detail. Um, let's quickly cover why. Okay, why why Amazon Elasticsearch? What is the benefit? Um, it's like a service. You don't have to literally see, if you want Elasticsearch, basically had to build your server. You have to set up your network, heartbeat connections, and everything, and have a storage, and build your application. And it's like you have to, this build process itself, it takes a couple of days, involving so many resources. And finally, you have to manage if something goes down, or if you wanted to add disk, or change, increase the node type or something, or CPU memory. It's all day-to-day administrative task. So like other services Amazon introduced, I mean it's a pretty old service. So this service, which is which makes you to deploy, operate, and scale Elasticsearch, in a very quick fashion. It can be used for log analysis, text search, application monitoring, any for these purposes. So it's a service. You just go and right click and define your requirement, and your cluster is ready. So you don't have to manage. It's easy to scale up, scale down, easy to take a backup and restore. It's a fully managed service. So that's what this slide talks. And also this service is built in, integrated with the Kibana Logstash. These plugins are already installed by default, comes with Amazon Elasticsearch, so you don't have to literally install those things. The moment you build the cluster, you ingest your data and start using Kibana and do the reporting or whatever you can create right away. And also you can you can integrate this service with other services like Kinesis Firehose, Lambda, or CloudWatch. What is Kinesis Firehose? Basically, it's a streaming service which takes all your live streaming data, and and then finally it ingests back to Elasticsearch. So you can, at a time, you can grab, you can configure multiple sources like Facebook, Twitter, or anything to get the live data, give it to Kinesis Firehose. Then Kinesis Firehose knows how to write it back to Elasticsearch. So, or you can use the Lambda, to, let's say, for any event from any other service, your Lambda can trigger and create the get the data and ingest into the Elasticsearch. So like that, it's kind of integrated. So there are lots of advantages of using Amazon Elasticsearch. Okay, so finally, how Elasticsearch stores data across cluster node. This is the picture I wanted to talk. In fact, we covered a couple of terms there, right? I'm just trying to give it in a pictorial way. So let's say this is your cluster, high level. It's a two node cluster. Okay, when I say cluster, at least I want at least more than one node. So it's a two node cluster. It built with let's say 50 GB hard disk, just one disk, 50 GB, 50 GB on each node. Now, just two node with 50 GB. The user, it's already built with, installed with cluster and everything, Elasticsearch application. Now the user creates an index 0. As I mentioned, index is nothing but the database kind of stuff. I'm creating an index so that I'm going to upload all my logs into this CloudWatch logs into this index. So I create the index. The moment I create the index will create something called shard. It won't be stored just like that. It creates something called shard. The shard is nothing but the logical partition inside your uh, underlying hard disk. It's like, assume it's like a file system or logical partition. So how many shards created? This depends on whatever you mention. When you create an index, you can say I want multiple shards or one shard, and how many replicas you want. That also you can mention. So in this example, let's say I'm creating an index with a 4 shard primary shard. The greens are primary shard and one replica shard. So when I say one replica, every shard will have one replication. So look at this one. The moment I say create index with 4 primary and one replica, the shards are equally balanced across the nodes. Shard 1 is created, shard 2 is created, shard 3 is created here, shard 4 is created here. So shards are balanced across the cluster node. And look at the replica. Shard 1 and 3 replicas are copied over here, and 2 and 4 replicas are created over here. Okay, so in this way, if node A down goes down, still you technically have shard 1 and 3's replica you can reconstruct, and 2 and 4 is here. So all of your data is still with the uh, one node. So assume tomorrow I am adding one more node called node 3. So in this situation, your shards will be balanced across 3 nodes automatically at the background process. It just rebalanced across 3 nodes or 4 nodes or 5 nodes, whatever you introduce the new nodes. So one important thing to remember, the shard, how big the shard can go, it depends on the actual underlying disk size. If you have 50 GB disk, you can create 1000 shots, but you cannot store more than 50 GB data. Okay, that's the limitation actually. So you can create as many shot, you can create as many replica, but all once again comes under to the actual disk size. And in fact, you can have more than one replica also. The replica is nothing but just the duplicate copy. So if your shard, let's say shard one is taking shard 1, 2, 3, 4, all the shards are consuming 10 GB of data. Your replica is going to be another 10 GB. So remember that. So when you create more than one replica, you're going to have more than 10 times of, or if you create 10 replica, you're going to have 10 copies of your production data. So that size needs to be considered. So so I hope this is helpful. So when you create a cluster, very first thing all you'll do is create an index. The index will automatically create the shards. Of course, you mentioned the number of shards and replica. This index will create the shard, and shard will be automatically balanced across the node, and replicas also automatically replicated, I mean placed across the nodes to take care of high availability. Hope this picture helps you, and let's go to the further thing. Okay, AWS yes, when you go and create a Elasticsearch configuration, these are all very high level. We are going to do now. We are going to create the domain name, basically the cluster name, and this is the two versions available in Amazon Elasticsearch as of today. This is January 2017. So these are two cluster versions available, 2.3 and 1.5. If you look at the open source cluster, I think we are with the very latest one, 5.x something. We are not yet there. But if you want, you can install yourself in EC2 instance directly. But the managed service as of today with only these two versions. And when you configure a cluster, these are all the things we are going to configure: instance count, type. Do you want a dedicated master? And finally, we are going to have a policy, who can access from which IP, all those things. So this is pretty much, I'm done with the slides. So let's go to the actual demonstration. Okay, so I just created one cluster. Let me create one more quickly, um, because okay, yeah, create one more cluster. So let me go back. This is my console. In this console, I'm going to create, in the dashboard, I'm going to create a new cluster domain. When I create a new cluster domain, there's a domain name. It's basically the cluster name. I'm going to say example 01. And this is the version I'm picking. I pick the latest one. 1.5 is pretty old. In fact, 2.3 is not pretty new also. It's it's somewhat decent. So these are two options available. Um, Click next, and the instance count. I'm not going to give more than, you can give any number of instance count. The limit is actually 20. You cannot go, I'm sorry, you cannot give any number. It's like 20 is the maximum count. You cannot go more than 20. So here I'm going to give just one. Um, Instance type, these are all the available types of instance available. Based on your workload, you can pick the appropriate instance type. I'm picking T2 micro. It's a free tier. um, Remember, if you are building cluster for production, even for development purpose, don't pick T2, because T2 has its own CPU limitations. It's like it works on credit line, concept. So we are building a search engine. Basically, we are testing high performance. We are going to talk in latency level, response. So T2 is not the right candidate for Elasticsearch. But why it is given is just to do any POCs, just to get familiar. That's the reason T2 is given. I would say anything production, or development, or any critical, always go more than T2. And enable master, we talked about it. Master is a dedicated node. You can, if you want, optionally you can use it. This is going to take care of all administrative jobs, like replications, index creations, cluster node maintenance, those things, this guy will take care. Basically, your data node will be doing only storing and responding back to the users. So master node take care of rest. When you build, if you think you want a master node, mention at least three node. The reason three is given. If the master node is done, it's going to have all the metadata. If it is done, it's going to create the entire cluster like a crash or unavailable. Uh, in the cluster concept, to avoid split brain, any jeopardy situation, it's better to have three node. That's the funda, but it is not a rule of thumb or something. Anyhow, I'm not going to use master now. And another feature is enable zone awareness. If you pick this, basically we are building the cluster across the availability zone. Every region has, so I am right now with Oregon, every region in Amazon has multiple availability zones, nothing but data center across multiple locations. So let's say you are going to build a six node cluster. So your two nodes will be placed in one data center, another two node will be across a different city, different data center. Another two node will be in the third data center. In this way, it's really really highly available. Any kind of catastrophic like disaster, still you will have part of your environment working. So these are all, these two is the thing you can pick if you think your cluster is really critical, it's serving protection in those situations. Okay. I'm not picking those things, it's a test purpose. So storage, you can pick instant store or EBS. So depends on your instance type, you pick whatever you want. When you pick instant store, remember every type of instance has its own size of instant store. So you cannot get, let's say M3 medium supports 40 GB size of instant store, you cannot go more than 40 GB. Let's say you wanted to store 100 GB data, but at the same time you want M3 medium or something, then pick EBS. Okay, EBS, I don't want to talk much on this one. Instant store and EBS, you guys know that. um, so you can pick the volume size, and you can say whether you want to provision IOPS or general purpose. So those things. And minimum size is 10 GB, and maximum size of EBS volume can be 512 gig of a GB, of a terabyte. I'm sorry, you cannot go more than half terabyte. Um, and also every instance can have only one disk, not more than a disk. If you have a 20, as I told you, the in Elasticsearch, Amazon Elasticsearch cluster, you can have maximum of 20 nodes. So each node can have maximum of 512 gig, and that's the limitation actually. You cannot go more than 10 terabyte of storage space. Okay. Once again, the 512 gig disk is not really available, supported for all the type of instance. Let's say I picked T2 micro, right? In the T2 I cannot choose 512. Let's say if I go 512, it will say, hey, for the T2 type of instance, your volume size can be between 10 to 35. But if I pick M3, probably I can go 512. So mm, look at the public documentation. They have, with nice documentation which explains which type of disk is, which type of instance can take how much big size of EBS volume and all those things. Okay, snapshot. So this is a very cool feature. When you build a cluster, you can define by default automatically, the day one your clusters snapshot is taken care by Amazon. Default one snapshot will be taken care. So you can pick the time. Let's say by default it is midnight. If you think, hey, my cluster is too busy in the night time, so and I would like to schedule my snapshots other than midnight, you can pick the time. Okay, it's like a schedule you can pick. Um, this is a snapshot taken by Amazon. Anytime if your cluster failure or your index is lost or something happened, you can very well contact AWS support team to restore your previous snapshot copy. Okay, that's possible. Okay, so next this is important, access policy. It's kind of it's IAM policy. This is very important. Here we are going to tell with whom we are going to give a permission to access your cluster. So by default, these are all the templates available. You can pick whatever you want. Um, Allow or deny access to one or more AWS accounts or IAM users. So basically, you can control access to the accounts or IAM users, specific users, by using this policy. So you can just mention the account ID or ARN. I'm not going with that. Or you can define for specific IP address. If you mention your, let's say you are the only one going to do, just mention your public IP. So the actual policy will be created. Or you can go for uh, completely deny or allow open access for everybody. So remember, allow open access for everybody, which is going to be very critical. Anybody in the world can access your cluster. They can also create index and delete your data. So uh, I would say please don't use it. For a demo purpose, I'm just doing it. But if it's a real critical data, please don't ever use this one. Okay. So this simply says anybody can access my domain. Okay. Let's say I'm going to use only my IP. I would say allow to the specific IP, and I can find my IP like my IP. If I say my IP, this is my IP. Even I can give my IP over here. So only specific IP is created. So you don't have to create or policy or something. It's so simple. So for a demo, I'm just allowing everything, so, to ensure. Okay, and one critical thing, since it's a managed service, you can access Amazon Elasticsearch only by contacting the public endpoint. It means public IP. Okay, if your private IP is within your VPC or something, you wanted to access the Elasticsearch cluster, then you may have to build a NAT instance or a proxy instance and come through that to access your Elasticsearch. Okay, this is always accessible from public IP, through public IP. So remember that. Okay. So next, and see, that's it. Everything is done. This step is going to confirm and create the cluster. This process takes like up to 10 to 15 minutes. We don't want to waste time, so I just gave you the walkthrough. But with this all sitting, I already created one cluster. Let's go quickly take a look. This is the cluster I created. Okay, AWS group. I just created few hours before. So uh, same kind of specifications. If you look at the cluster status showing yellow, why it is so? Whenever you build a cluster with a single node, one node, your cluster status always going to show yellow. But still fine, you can do all the features, everything. But only thing it's warning you, you don't have a high availability. That's what it is yellow. If you have a two node, it's going to show green. Okay, and this is important active status. Click on this one. Once cluster is created, it's going to show active and version. This is your endpoint. By using this endpoint, this is accessible only through public IP. By using this endpoint, you can create index and everything. And this is for Kibana, basically for reporting purpose, monitoring, what you call analytics tool. It's already installed. And it says number of node 1 node, I just created one shard also anyhow, and indexes. I created one index called customer. I'll walk through one more time, and you can do monitoring also. I'll walk through this a little couple of minutes later. So so this is how you should see. And if you have more than one node, this will be green. Remember that. And let's quickly access this. See, this is my another website. Basically, I created this for uh, Linux training purpose. I have lots of Linux modules. Here you have one called, you can search for Elasticsearch. Mm, this is the one, Elasticsearch. I captured basic Elasticsearch commands over here. With this, you can try some of the basic command. If you want to install Elasticsearch on your EC2 instance, like other than using a service, you can install the package, and and you can start the service and use. This is a regular way. And anyhow, this is a thing we are covering. So in this example, all I mentioned is localhost colon 9200. If you install cluster, by default it will come with the port 9200, and it's going to replace your actual host name. But in our managed service, we are going to use this endpoint. This endpoint will respond by default with port 80 and port 443. So it's not going to listen on 9200, it's port 80 and port 443. So that's it. So let's connect to this server, and there are a couple of commands I would like to run. This is the command I would like to walk through. So this is curl my domain URL, whatever we created, and underscore care and health. This command tells you this is a API call to find the health status of your index. Um, this tells me, this is your cluster name, status is whatever you see on the console. That's the same thing. Number of node, number of shard I created, one shard. So those informations. And let's say I wanted to see the number of nodes. So specifically, so I can see cat nodes. This command gives, oops, this command gives me how many nodes in your cluster. If you have multiple node, it's going to tell multiple node here. And these names are a default name given by Amazon, and you don't know the IP address on those things, because it's all masked. um, and if you want to know is there any indexes created, as I mentioned, I created one index called customer. So I do see the index called customer, which is created with one primary shard, one replica shard. Because I have one node, there is no point in creating multiple primary, because anyhow my shards are not going to spread across multiple node. If it's a one node, my logical partition, keeping multiple primary doesn't make sense. You can keep one primary, and in fact replica is not required. I just created one replica. It's a default one. And this is the if you want to create an index, basically this is the previous one is to list the index. This is to create the index called customer. Xput is the thing. If you do xgut, which is going to get, this is actually xput. Let's create one new index called, instead of customer, let's say example. you know uh, I'm going to create a new index. So you would see acknowledged, true, which means your index example is created. So let's, in the example, I'm going to, let's say in the example index, I'm going to create something called, this is called mapping. I can create map 1 or today's date. We talked about it, right? It's a type, it's not mapping, it's called type. um, in the example index, I'm going to create one kind of a table. That's what we talked. Type, this can be any name, for example customer 1 or 2 or whatever, or app 1 or something, app 01. There I want to put this JSON file. This JSON file has just got one entry. Assume you have a JSON file which has the movie database or anything with like million rows or something. Still the same procedure. Let me see. I think I have some typo over here. Okay, because I removed one of the colon or something. Let me try with this one. Sure. Okay. So I created a index example, and in that I created a type called external. Technically, you can create any name. Instead of external, you can say one or something. And inside, I created an ID called one because every document is going to have one ID. And there, I copied my data. This is the example. And let's say I wanted to get the document. So we just copied pasted document, right? This is X put, right? This is X get API to see whether we are able to query the document. So this will tell me my AWS group. So these are all the basic thing. As I mentioned, you can go to this website mylinuxguru.com where I have a detailed example. Search for Elasticsearch commands at the bottom, and you will have lots of examples how to retrieve, how to delete index, and how to modify data. You know how to do batch process, and how to create a template. Basically, template will have an predefined data format and everything, so that once you create a template, it's going to follow that. Any index with the name T star will follow that template and build the index. So this is a huge actually. Our objective is to cover what is Amazon Elasticsearch. That's done. Elasticsearch itself is huge. As I mentioned, it's an open source. You can go and look at the open source document and try whatever you want. It supports pretty much all the API calls. Um, okay, let's go back quickly and cover monitoring. Okay, so far we created two index, right? Customer was now we created example, I just added only one document. That's what here, which is under external. The size of the document is given here. So this is another way you can check in the console how many index you have, how many records you have for per index, all those informations. And monitoring is very important. Let me take a couple of more minutes. Um, it's a CloudWatch. You can see up to 14 days of report. Your cluster status should be green. Then only you can able to read or write the data into the cluster. Important. Okay. Uh, it can be yellow or green. If it is a single node, of course it's going to be yellow. If it is red, then it's inaccessible. See, today red is in a 0. If red is in a 1, like the projected, then it's going to be a problem. And remember what situation it will become red. Something happened at the host level, or if your one of the shard is got corrupted, or let's say your one of the underlying node disk space is 100% full, you are no more able to write the data, or your CPU is 100% and the cluster become unresponsive, or your memory becomes heavily used, cluster become unresponsive. In these situations, the cluster will become red status. I do see number of node 1, and anytime you add the document, write data, it shows how many number of document. So it's number of searchable document. If you have million rows, a million records written, then it's going to be a huge spike here. How many deleted, and CPU usage of your cluster. It's gonna, if you have, today we are playing with one node. Let's say you have a 20 node. It's going to give an average of CPU usage across all 20 nodes. Okay. See, you can click here and go detail, and and you can even go for last 2 weeks. Average, you can do all. It's pretty much standard CloudWatch report. Free storage this is very, so CPU is very critical. Always take a look. We don't want to go more than 80%. Free storage space, ensure, um, always look for a free storage space, for not the sum. I would always look for a minimum. Don't look for a sum or maximum, always look for a minimum. What is the difference is, let's say you have a 4 node. Even in one of the node, your disks, all assume all the 4 nodes has 10 GB disk. You are writing one index on node A, first node. Your 10 GB is full 100%, but you still have lots of disk space across other node, but still your cluster will go to red state. So minimum will tell what is the minimum storage available at in any one of the node. Okay. Again, if your 4 node cluster, 3 nodes has plenty of space, one node is with no space, this minimum is going to show the one node. Okay, the maximum is going to show what is the maximum space available in any one of the node. The sum will show what is the maximum space available across by adding the spaces across all the cluster node. So I would say always check minimum. Okay, this is very critical because cluster reacts even if one node running out of a space, your cluster is going to be in a red state. Okay, so look at this one. And possible configure a CloudWatch alarm to do the proactive monitoring. Okay, um, yeah, free storage space. Yeah, summon minimum. So I would say I'll watch always minimum. Okay, and JVM. This is another critical piece. Always look for ensure your JVM is not going more than 75 percentage. Up to 75 is okay. 85 you are in a critical state. More than 85, anytime your cluster can go to red state. So always look at this also. Okay, you can look at that trend. And snapshot failure, remember we at the time of creation I mentioned automatically Amazon creates a snapshot. Always watch you don't have any failure. Anytime if you have a failure, the graph will go to 1. So if you have a failure, uh, it means what situation failure will happen. Your cluster is too busy. That could be one cause. No resource left out, or you have one corrupted index. Then you have, let's say, 20 index. Out of 20 there is one index is corrupted. Even in that situation your cluster snapshot could fail. So watch out this, because in case of any overall cluster loss, this is the backup, right? uh, One quick note, other than this automated snapshot, you yourself can create a snapshot and keep it in S3 bucket and restore yourself. I'll try to cover that in a different video. That's a quite lengthy process. I'll try to give another presentation on that one. So you don't have to really rely on Amazon snapshot. You can create your own snapshot too. Okay, that's what it is. This is the read IOPS, write IOPS. These two are like how much reads and writes with respect to the disk cluster, and this is a latency, how many milliseconds it took for you to write the data and read the record, and this talks about CPU, I mean disk queue, how long it took, and those are all pretty much EBS volume statistics. CPU, since I used T2 micro, I'm seeing this my credit balance. As I mentioned, T2 is not the right candidate. Remember that. So, what is CPU credit? Just Google it, find out what is Amazon CPU credit, you'll understand. And delete. Finally, if you want, you can delete the domain. In fact, I'm going to delete the domain because I need to pay for it. So that's it. Once you delete that, even including snapshots, everything is gone. You cannot restore. Remember, okay, deleted means completely wiped out. That's it. Before you delete, if you think it's really critical, you take your own snapshot and keep it in your own S3. That's the only way you can restore. Okay. So automated snapshot is only used in case of any hardware failure or any index corruption. You can approach Amazon to restore. That's not going to be used at the time of deletion purpose. Okay, that's it, guys. I'm pretty much done. Hope this is helpful. I'll try to cover some other topic in my next video. See you next time. Bye.